Well, hello, my name is Jon Debonis. Thank you for coming today. This is an opportunity that I want to present how we can make things a lot more secure in our environments. Now, there's a little context to this that I should put out there, which is I had the opportunity to start working at Blend when there was 20 people, and we could really define, like from a greenfield perspective, how we're going to do security. And since then, we've been able to maintain some really strong security architecture and security design in our systems. And so what happened is after a little bit of time, we started hiring more and more engineers. And at first, there was 4 people that had access to our production infrastructure. They could SSH to machines, they could go to the databases. But then we hired, we hit 150 people in the company, and we had 50 engineers at that point. And a lot more people needed access into these databases and these backend systems. And so 4 people, 10 people, we started to lose the ability to control how many people had access into our environments. And what that opened up were a whole lot of vulnerabilities. And I think like most of you, we look at what our threats are. We try to figure out what the next step is, how to assess like where we might have risk and go and try to fix it. So doing that, there's these kind of common attacks that I reference a lot because they impacted the way I think about security. 2009, Google, which is really known for having strong security, a lot of engineers, a lot of protections, and all of my email data. They were hacked by somebody, probably the Chinese government, and those Gmail accounts were accessed. The way they got hacked was an email that somebody opened and looked at, and that ran some code on their computer, and the attackers were able to get access to this giant Google network. 2011, RSA, similar story. RSA, of course, invented the security we use on the internet for HTTPS. They're supposed to be a great security company. Our federal government, lots of healthcare, rely on RSA security for their second factor for authentication. But they were taken down because somebody opened an email. And the third one here on the list is Anthem Blue Cross. Same situation, 37.5 million medical records, including like my just born daughter. That information is now exposed and vulnerable. When the US government did a report to analyze what happened with this company, the security auditor said that they had fantastic security posture, like better than what's expected for this company. And so I think that fundamentally, if all 3 of these giant, well-secured companies can't keep their data secure, what are we all doing wrong? So the proposal, the solution is to use a dedicated secure device. So with a dedicated secure device, we're going to solve some pretty tough trends. We're going to solve phishing, malware, and credential theft. I'm going to tell you how to do it in a minute. But before you discount me as like a snake oil salesman or some other thing, I mean, we've been hearing that we can solve these issues for a long time. I want to put a little hope in this talk. So better security is possible. This is a list of a few items that have changed the way that security works in our world today. And the reason they're here is they've eliminated entire classes of attacks from being effective against people. So let's pick 2 to talk about real quick. How about development environment? We have a lot of developers here. We haven't completely killed cross-site scripting, but if you're using a framework like React.js, it's very hard to accidentally do cross-site scripting. Like you have to almost try to do it at this point. What about binding SQL parameters? I don't think there's not a lot of libraries that lets you draft your own SQL statements any longer. ASLR, we know that's been effective. Automatic updates didn't exist for the longest time, and it's hard to remember back when Microsoft wouldn't push out updates, but for a long time, you couldn't get your operating system updated, and this was a huge change in the industry. So the point is, there are simple things we can do in defense that once we roll it out, it changes this equation at the bottom. Right now with phishing, for example, it's really cheap to launch a phishing campaign, and it's really hard to defend against it. For example, to defend against phishing, one way to do it is you either buy all the vendors' stuff that's out there, or you have a team of people that opens up every single email and manually, statically, or analyzes whether or not they're phishing. One of those ways will work, but it's really expensive, so it's not practical. So I'm going to propose a problem today is that we have a general purpose laptop and we try to make it secure. On one hand, we have developers that need to use a laptop, they need to compile code, they need to run the code that they've built on their laptop. They need full access to it, and they need to install tools so they can be effective. In fact, we want them to. We don't want to get in the way of them installing things on their laptop. On the other side, we need to secure those laptops if they're going to be accessing sensitive information. We need to load it up with anti-malware, forensic software, all kinds of tools, and we need to lock it down. And so my proposal is basically the one size doesn't fit all. You can't have a general purpose device that's also secure. That's kind of fundamentally what I think is wrong with the way we've been trying to do this. So let me just go through a few of these real quick. I'll talk about the 3 common attacks again, talk about what a secure zone is, and how to deploy a secure dedicated device in your environment today, or at least how we did it, some of the things that we learned about it, and how other people can get started. So here's a scorecard. The very first threat is employee productivity. One of the biggest challenges with getting security on a device is that employees push back. They don't want to be locked out of their device. And so the mitigation, secure dedicated device. So let's talk about malware. It's a broad topic. There's basically 3 types of malware that happen. There's that one I talked about where somebody opens an email and somehow that email takes advantage of a vulnerability in the email client that runs bytecode and then installs some kind of malware. Now malware then needs to figure out a way to persist so that the next time the computer is rebooted or when the email client's closed, it can still live on that machine. And that malware needs to elevate privileges so that it can get enough rights to, both persist and, open up a backdoor or whatever the issue is. I'm calling that drive-by malware. The other one is somebody sends you a new video game or some executable, or you go to the App Store and you saw a calendar. This happened a few months ago, and that calendar installs some kind of spyware, or I think the calendar app installed a bit mining cryptocurrency tool. And then the third one is something that's a little bit more for the developers. You might do an npm install of some third-party package that runs a script that could very well install some malware as it comes through. I know that it's called poisoning the well. I know there was an npm package that would send off your environment variable to a third-party server. But ultimately, for the drive-by download, the mitigation is you need to keep every piece of software on your device patched from the operating system all the way to all of the viewers. For the Trojan, the best mitigation is typically application whitelisting, right? So if we had a device where you could only run trusted applications on, then you would be able to keep those off of there. And the third one, in terms of the developer thing, this is why I said that you still have your general purpose machine where you can do your development, and then you have this one that's dedicated to accessing secure areas. So malware basically kills off these 4 threats. With auto-patching, the persistent one, the mitigation's a read-only operating system. Trojan malware, whitelisting, and then privilege escalation. No admin rights, but also the read-only operating system. Okay, so the second one is phishing. I don't think I have to go into detail about what phishing is in this group. It's still a huge problem across a lot of companies. A lot of the breaches from Verizon still point to phishing as being an issue. So when we hit 150 people at my company, we sent off the first baseline phishing assessment of my company. And we were shocked when 20% of the people either downloaded the malware or clicked on or gave credentials up. 20%, this is before we trained them. And so we started doing a huge push out of training against the company. And we've gotten the number down to no credentials and maybe about 2% of downloading the attachments in a malicious email. 2% is pretty good. It's not good enough. It only takes one to compromise a group, as we saw from those attacks earlier. Verizon also has research that says that across the board, every company, 4% is the average. So phishing's not going away. Email continues to be the most common vector for phishing. They group telephone calls and a couple other phishing variants in here, but that's the primary one. So the mitigation on a secure dedicated device is really simple. Turn off email. That's it. The third one here is credential theft. This is essentially the idea that once you get a foothold into a network, now you need to laterally move across the machines to elevate your privileges. This is especially present in the Anthem breach, where I think over 50 accounts were compromised before they were able to get to the database. The solution for this one with a secure dedicated device is going to be having a hardware security module on the device that can store that credential and that you can't extract that credential later on. So all in all, we have solved a few threats simply by this concept of a secure device that we can control the security for. The next part to talk about is the secure zone, so a secure area. Basically, the idea is that your data center where your secure information lives, it kind of has the idea of that there's a front door, which is, if you think about a retail shop, there's a front door where you go in, you look at all the clothes or whatever they're selling. And then you have the back door, which is a service entrance, which is where all the deliveries come in, the maintenance people come in, and the staff come and go. And they're completely different profiles in terms of, from a security perspective, how we're going to defend against them. So the way that we see the secure device coming in is through a VPN into a service zone. And the idea here is that the service zone, a lot of bad things can happen there. I mean, people are coming in that can SSH into boxes. It's not just web traffic. And I like to point out that I never, when I build a security architecture, I try not to rely on one single control. I know a lot of people have their VPN directly connected to their secure zone. I like to have a second layer there. My VPN connects to a service network. And on that service network, you can SSH to a jump box. And once you're on that jump box, then you can get to the secure zone. And what this does for me is it lets me sleep at night. If there's an issue with my VPN, I know that the bad guys still have another wall they have to get to. The second thing is it's a choke point. So even if you did break into this VPN or you stole some credentials, if the attacker didn't know exactly how to use those credentials, they may have to scan that service zone. They might have to, knock on some doors that they aren't supposed to try to open, and that's going to set off alarms for us. So for me, a secure zone, when you're accessing it from a service zone, it should be a pretty clear way to detect intrusions and defend against it. But ultimately, the other thing is that the secure zone should never have a device connected to it that's not secure. And that's where we're coming from with this secure dedicated device. So one of the things with lateral movement is, let's say somebody does breach my MacBook. There's no way for them to laterally move into my secure zone or into my Chromebook, and that's the point of this. The other part of this is that VPN is actually going to check that you're coming from a Chromebook. And so I keep generalizing secure dedicated device, but we implement it with a Chromebook. And the other reason we have an HSM on it is because generally, if you want to authenticate a device, there's going to be a certificate or some kind of secret on that device, shared key, something. Now, if I had a MacBook, that secret might live somewhere on my file system. I could copy that secret, and I could copy it to any other device. If I was an attacker, I could sneak onto that laptop, grab that secret, copy it to my personal laptop, and now I can connect to your network. So for me, the trick here is that you have a hardware security module on that device, and then you cannot extract that secret. So you can't even get on the network in the first place. So that's how we protect the secure zone and why we need a hardware security module. Okay, so now I'm going to move to how we actually achieve this with our hardened Chromebook. So step one. Well, this is the overview, right? So this is a Chromebook with the HSM. We are using Google Enterprise Policy, which implements a few of the features we were talking about, like whitelisting. On the VPN, we're using the Google Access Verification API. And what this does is it verifies that a secret coming out of that HSM from that Chromebook, it proves the identity of that Chromebook, and then it cross-references to the Google Enterprise to make sure that Chromebook's actually registered with the domain, and it has a policy in place that we're looking for. So step one, you set up your Google Enterprise policy. And the way we did this is we created a brand new Google Apps account that's separate from our primary domain. So we have a new domain that is dedicated accessing the secure zone. And then on that, we set up the Chrome, we turned off email. So it's a Google account that has no email. You buy Chromebook licenses, then you can start setting up the policy. We did an application whitelist at that point to only allow the certain applications that we need. And those applications, those are VPN. It was an SSH client. It'll be a remote desktop client as well. Step two, and this is the fun part, this is where you tell all your engineers that they have to carry two devices now, and they're not that happy about it, but they do understand it. And what's amazing about this part is how easy it is to deploy those devices to them. We don't have to flash them. We don't have to, we don't have to image the device. We get the device out of the box. We log into it with the administrator account credentials. It pulls down all the software it needs and the policy. And from that point forward, it's already secured. It's a little bit too easy, to be honest. Step three is where things actually get a little interesting. So in order to use the Google Access Verification API, we had to spend a little bit of time working with Google to get the documentation, get the thing enabled for our account, and figure out, we had to write our own extensions to take advantage of it. So that's the first problem. The second problem we had to fix was there's no VPN out there that automatically supports the Access Verification API piece of this. So our first stab at this problem, we didn't build a VPN, we built a proxy server. And the way it worked is we have a certificate authority that can sign a certificate if you can prove through the Access Verification API that you're a managed Chromebook. Then we return that signed certificate, and that sets up a MASL, a mutually authenticated TLS session to our secure proxy. And then over that secure proxy, we have the user log in with their usual Okta credentials. And this has worked okay, but it's limited the protocols that we can use across that connection. So what we're working on now is we're using a VPN that's open source called WireGuard. That's interesting in that Linus Trovad has endorsed it as being the best VPN he's seen. And they're actually working to implement the kernel module in the core Linux kernel. In any case, what we're doing is we're building the user agent piece of this. So the Chromebook can use it to authenticate using the access verification API and like Okta credentials. So this is a scorecard. We've been able to mitigate all of these threats using a secure dedicated device, specifically the Chromebook. One thing I haven't mentioned, I don't know if everyone knows, but Chromebooks actually have a few properties that are amazing. They're inexpensive, relatively. A good Chromebook will cost $500 on average. They are managed, right? So you don't have to buy additional management software or configure it or have an IT team go out and deploy all these things. And they have a really great security model to begin with. So for example, on here, I have a read-only operating system as a way to prevent persistent malware. The way that works is just like the iPhone, the operating system, the core, it checks a checksum against it every single time it boots up. And if anything is changed, then it bricks the device, basically. So if there was a way to bypass and escalate privileges to modify the operating system, the machine wouldn't boot up the second time through. The automatic patching on a Chromebook is a pretty amazing story. They recognize that nobody likes to wait for their operating system patch. I mean, I think Windows takes forever, OS X takes forever. When you have to click that thing, it says download a new operating system update, you kind of dread it and you kind of put it off. With a Chromebook, it's cool that it has two partitions. It'll download the new operating system behind the scenes, stage it so that it's ready to go, and the next time it reboots, it'll actually boot off that second partition and set the first partition as ready to be wiped and download the next update. In other words, you get instantaneous operating system updates on the Chrome OS. Also, the Chrome extensions push down their updates automatically as well, so you're constantly patched. One thing I forgot to mention about patching in general is on the general purpose device, even if I don't give my employees the rights to install software on their own, they will still open up tickets with IT to have software installed, and IT will still install software. And so what happens is you end up with a whole lot of applications at different versions on a whole lot of devices. And so then IT is going to go and run a tool that says, well, give me a list of all the applications, all the versions. And now they're going to have a huge list of applications and versions, and they're going to have to cross-reference that to all the versions that have vulnerabilities. And then they're going to have to say, okay, all these versions have vulnerabilities of all these applications, and then they're going to have to go and figure out how to push out those updates for those vulnerabilities. And what happens in practice is nobody does this because it's too hard. It is a game that can't be won. Now you go back to the secure dedicated device, and you only have 10 applications that have been whitelisted, and you make sure those get patched because it happens automatically to start with. But second of all, you can spot check that set of 10 applications on a quarterly basis or something. All right. So how does it work in practice? This was a offsite, I think a month ago. It was a training offsite, and there was a production outage, and we had one of our engineers who was working to resolve the issue. And you can see he's got his general purpose laptop where he's doing his communication on Slack or email, and he's got his Chromebook where he's actually on the network doing troubleshooting and diagnostics against the servers themselves. And so this is an offsite. He obviously has to carry his laptop with him so that he can do this work, and he's on call, and that's why he has it. But we have deployed 100 of these at this point, and so far the response has been pretty much okay. One of the things that has happened when we rolled this out is the teams are building more tools so that they can get diagnostics for the services they're running in the secure zone without having to go to the Chromebook. So they're making safer access into the environment easier and more ubiquitous because sometimes they just don't want to deal with a Chromebook. And so that's making me happy because we're getting more access to more tools without having more risk of people connecting to the environment. So you can actually get started with this today. Again, I said the biggest challenge we had was a VPN piece. Chromebook does come with a VPN. It's OpenVPN. It's really difficult to configure, but there's documentation out there. Everything else in the Chromebook is ready to go today, which is pretty low barrier to entry. I think, what I would love to hear is that people are starting to use this in more and more places, maybe more and more secure environments. Maybe you can isolate like the most sensitive area and say only Chromebooks can access that. So again, being able to eliminate that entire set of threats is a big deal. Phishing, credential theft, and malware, making those go away is a big deal. We've been fighting this for a long time. I think that we can do that here with a Chromebook, and I would love to hear more from people that are doing this or similar things or want to get started. That's it. Anybody have questions? Also, how much time do we have?
So the VPN thing, how would you advise any company with just a plain like Google app organization, no Chromebook, nothing to rely on a Google managed VPN as much as possible?
Are you asking if there's a managed VPN?
Sorry?
Oh, I'm sorry, was the question?
My question is, so my company, we use Google authentication for Google Apps for everything. And we'd like to build a VPN on top of this credential management by Google. What would be the best solution on your point of view for this?
Yeah, I think the best solution I know of is what we're building, which is the WireGuard implementation. We are going to open source that probably by the end of this year. But I don't know, we didn't find any open source or trusted VPN solution out there. So one thing we don't like to do is rely on a closed source client or a closed source server side. We want them to be open source so we can evaluate the code and make sure they're secure. So we haven't found anything great other than those custom solutions.
We have 6 more minutes.
Oh, 6 more minutes. Cool. Well, we can do questions. I can talk about a few other things.
Okay. So this sounds very interesting. My first thought, though, is that I've got 2 devices now, and there's some reason why I have to share data between them. So I'm going to use a USB stick and transfer data between them.
Sure.
How does that handle?
Yeah, it's a good point. We actually don't allow USB sticks on the Chromebooks, but when people do need to move data across, we have something called send.blend.com. It's based off Firefox's send.firefox or send.mozilla.com. So we send secure files across that way. Yeah, but we don't disallow like Slack on the device. So there are still ways to get data on the device. It's just people don't use it for their like day-to-day, like email, or they're much less susceptible to. Slack is closed, right? That's a closed conversation thing. Email comes from the outside. That's where the phishing stuff comes in. So in my opinion, it reduces the risk a lot, but we still have ways that people can get data across. Say again? We do allow general browsing. That is probably an optimization we would take away at some point, but again, it's not like their primary device, so they would only be on there like searching Stack Overflow or something for solutions to issues. Yeah.
Hi, I had a question. how do you add a new provision, a new Chromebook in the management API?
Into
Or
the what?
You have Google Management
Yep.
API for adding a new Chromebook. How do you actually go about doing that? Is it a manual
Oh.
process?
So as part of the Google Enterprise is that one of the admins on the Google Enterprise account, only they can add a new device to the environment.
And do you use a Chromebook for doing that?
It's not locked down to the Chromebook for adding that. So if you were able to compromise an admin's account, you could potentially get your device authenticated for or provisioned to be part of the domain.